looks like you're ready to go.
Okay.
Next speaker is Dr. Wayne McCain, Athens State University.
And Colin, who did a lot of the research initially, and he's going to set it out and watch. He's actually taking his first speech class at Calhoun Community College right now, so he's declared he's not quite ready. Could we dim the overheads a little bit back there? Skip, do you know how to do that? I always like to not have so much glare in my eyes when I'm doing a presentation there. Okay, well, most of you have already seen presentations on our proposal for a radio astronomy CubeSat. We first presented it at SARA Western Conference in 2017. We presented it here last year at our annual conference. We've since made several other presentations at Alabama Academy of Science, several different organizations since then. And what I wanted to do today is it's going to be kind of a short presentation because I'm not going to go into the great detail that I normally do, although that information is in the paper and there's color handouts on the table outside of the PowerPoints and the paper. But basically, you all know very, very well that there's a whole lot of radio science out in the universe that can't be assessed using optical astronomy. So that's basically why we're here. And a couple of years ago, really, we started talking about the possibility of doing a CubeSat project. And we wanted to develop a science mission around that. And basically what we've come up with is to do a CubeSat that would receive low frequency and very low frequency signals above the Earth's atmosphere, those that are typically blocked by our ionosphere. And there's lots of science out there ranging from SID type information from the sun to supernova, pulsars, black holes, AGNs, just a lot of things that can be done in that part of the spectrum. And as it shows over here, the problem with Earth observations is that during the day, anything below about 10 megahertz, and I think at night it's around 5 megahertz, totally blocked. The Earth's atmosphere just makes that opaque. So even the VLA, can't do much science in those areas, or at least it's restricted. So very briefly, what's a CubeSat? Just talking to Jeff back there, things are changing so rapidly in small satellites it's hard to keep up. But a CubeSat in a 1 unit size, 4 by 4 by 4 inches, pretty small, weighs about 3 pounds, okay? It's got to be self-contained, totally autonomous from the launch vehicle. And the typical launch is that the CubeSat rides piggyback on an existing payload. They're normally deployed after the mission payload is deployed. A lot of STEM and student involvement, everything from design to building, testing, collecting the data, analyzing the data. This is a 1 unit CubeSat size right there. So, also CubeSats are launched from the space station. They can go up on a cargo vehicle. There's a special P-pod thing that kind of Gatling guns them out into space after a certain time. So anyways, lots of ways to do it. So we have changed the objectives of our mission since last year and made the primary objective science education for kids. Science, technology, engineering, and math, K through 12 and higher, everything, mission planning, ground station operations, data reduction, correlation, whatever. So the main mission now would be STEM. And so the science part of the mission would go to secondary objective, basically, where we would actually develop a receiver of some kind that would receive these signals. We've looked at possibly a variant of raster or some of the other smaller things, and what's shown here is a simplified diagram. We've worked with AMSAT some, Jerry Buxton, their VP of Engineering, kind of in talks with them constantly, and so the science experiment that we would develop would potentially interface with something similar to the Fox series of satellites in a 1-unit size, something like what Vanderbilt and others are doing. Vandy has 2 satellites in orbit now, I believe, and we've talked with them. This is kind of a picture of a cartoon of what it might look like. All these interesting things coming from the universe at LF and VLF frequencies can't get in due to the upper atmosphere, but a CubeSat can receive these signals and retransmit them to an Earth ground station at VHF frequencies, like 2 meters, like we have a 2-meter download. Question?
So what's to prevent you from having everything overloaded by terrestrial signals?
Very good question.
Well, the ionosphere
That's
will help
part
you in that regard as well.
Well, don't be so sure.
Yeah, and this has come up. There's a lot of Earth-based interference that we might have to deal with. So we'd love to hear your thoughts. As I said, we're basically 1 year later, we're still scratching our heads in the planning session. So if you thought herding cats was tough, just bring this subject up. And, people are very interested, and then they walk away and wait for it to happen, right? Also, since then, we have gotten another group of students involved. This is a picture of the Athens State AIAA officers. We have a student branch of the American Institute of Aeronautics and Astronautics, AIAA, world-renowned aerospace professional organization. We have a huge section in Huntsville, the greater Huntsville area section, and so we have this student group. These are just the officers. There's 15 or 20 kids in this group that varies from term to term. They have volunteered to take on the project management of the CubeSat project and whatever other. A lot of these people, notice most, except for these 2 young ladies here, most of the people in the thing are adults that have come back to finish a degree, so they're already working at the Army or Marshall, NASA, someplace like that. So they occasionally bring a lot of technical savvy too. So these people have agreed to do that part of the project, and we're basically still trying to put a mission plan together. Here are if you recall, the last time I showed this chart to you, there were lots more organizations on here. We've kind of weeded it out to the people who are really going to participate, and this is what the list looks like today. Some support, of course, from SARA, the AIAA student branch at Athens, and these organizations, Vanderbilt has agreed. As a matter of fact, we've already signed an agreement with Vandy, and for a year now we've been waiting for their legal department to say it's okay. I don't know what's up with that. Florida Tech has agreed, definitely to work with us. David Fields, who couldn't make it this time, he's working with a group in Knoxville who already has a launch slot for a satellite, so he's helping us. Mel Blank at UNA, Alabama Academy of Science. I happen to be the current STEM education section chair for the Alabama Academy of Science, so I have a little bit of in there. They've agreed. AMSAT, about a year ago, offered us the possibility of using spare hardware. The only thing they didn't have in the drawer was a a qualified set of batteries, and we think that might be overcome.
You could, those aren't bad.
Yeah, and then Spark Academy, my daughter Amelia here is going to present a paper tomorrow. She has been attending a STEM school in Athens, and they have a NASA certified technology teacher, Jennifer Kennedy, who's just really outstanding. So they're going to help. So we do have people that are committed to help do it. And so here's where we're going to go with this. We had an opportunity, obviously, last November to submit a proposal to NASA to try to get a launch slot. After beginning the review of several proposals that had been submitted and won in the past, we decided, hey, you know, we're not ready. The biggest thing that concerned me was the funding. In the proposal, you have to outline in advance the funding necessary for the program. And so I thought, wow, you know, it's going to be tough to get that kind of commitment. As it turns out, reading the proposals that have won, the funding list doesn't have to be all that concrete. Like, they've had letters in there from XYZ that says, yeah, we're going to participate, we're going to provide funding in support of this program. And, you know, that's about it. So we can do that. We have a lot of people who agree to do it. So we are planning to submit a proposal this November and try to get a launch slot. And it's kind of like a chicken and an egg problem, because until you have a slot allotted, you really can't get a whole lot of enthusiasm in support for people to help you work on the project. So we think after we
Let me tell you a comment on that.
okay, sir.
And if you build your satellite, even though you don't have a launch slot, and you let the people know that you have one sitting and waiting, they get a lot of guys who never show up for launch because they feel shake and bake. And if you've got one that's qualified, ready to go, they'll grab you and set you on, because they don't want to send up a mission with an empty slot in it. So you could be the standby guy. So that, if you go back with that kind of information, and hey, if we build it and just put it here, they may come and say, we got a hole for you to go.
That's good. Yeah, I told Jeff here a little bit ago, he's my new best friend. Just met him, but wow, okay. I love him. So basically, in summary, this is what we're trying to do. It just seems to me that this is a project made in the heavens for SARA. Who in the world would be more enthusiastic to have a radio astronomy CubeSat other than us? I mean, I can't imagine anybody that would be more enthusiastic about that. So we're going to do it with the primary objective of STEM involvement. And I'm very supportive of anything STEM, even considered homeschooling. Amelia here a couple of years ago, until I finally came to my senses, and she came to her senses too. So I'm really for that. So we're going to try to work out the details of the mission. All of you who are working on SDRs and all kinds of antenna. David Fields, who couldn't be here today, has already done some antenna development work in Knoxville. We're planning, and SARA approved last year, a small budget to launch some of the hardware on a high altitude balloon. We haven't progressed on that yet, but we still plan on trying to do that and making it, if possible, part of the proposal.
Make sure you have a tracking beacon. They're hard to get back. We've done those too.
I can imagine so. And so anyway, that's definitely on the books. So the basic next step is to finalize our mission planning, get in a position to write and submit the proposal to NASA in November, and pretty much go from there. If we don't get an approval for a slot, like Jeff says, maybe we could go forward and have it ready to go, or something near that, so that we can be a standby. But that's where we're headed. We still think it's a viable project to pursue. SARA is natural to be involved in it, although if you notice, we're not saying that it's a SARA-only project. I mean, SARA is going to be one of several organizations involved, but it seemed like a natural. Okay, questions? Jeff, first?
Well, I don't know how detailed you want to get into this, but the first question I'd ask you is, what do you expect your data rate to be from your sensor? Because getting that data down to the ground is hard. And when I mentioned that global star modem, that's a really useful way you can get 10 kilobits per second out of it. If you're using a ground station with a LEO-based CubeSat, you're going to get maybe 4 passes a day with maybe maximum 15 minutes of pass. And so you don't get a lot of time to do the handshaking and get all your data down. With a continuously operating sensor like you're proposing, you're going to generate a vast amount of data. So I just wondered if that was something you'd consider. By the way, the batteries, you know where you get those? You go out and you buy a drill and you take it apart, you take the 18650 lithium cells out, they're space qualified. They're already accepted by NASA, you can use those, that's what we got ours. You buy 2 or 3 battery packs, you take them apart, you cycle them through, pick the best batteries out of it, and now you got your battery pack.
The Rockwell drill pack.
The Rockwell drill pack's the best one.
Okay.
Then
Good
you got
information. Yeah, that's my new best friend back there. Okay.
How much money are you looking for
Well,
when you said you needed money?
yes, we don't know how much money we need because we don't have the whole thing planned. I know that Vandy spent $200,000 on theirs, and they had a government contract that they were able to get support from because of their mission. Vanderbilt has their objectives have to do with assessing the radiation effects on semiconductors in space.
Very, 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 very important topic.
It is, so there's a lot of government support already there, but
Is that a high altitude, Leo?
well, I think the latest one they put up is higher than the first, but I think we're talking 400, 600 kilometers.
Radiation effects within Van Allen belts aren't that bad for semiconductor stuff, and that's why you're able to get along with things. I'd recommend for your receiver system, one of these little sticks, a Raspberry Pi, and a ferrite loop with an up converter, and then that would be small, because deployment of antennas off CubeSats
Tough.
is very difficult. And
Yes.
they don't work well on one use, because there's not enough ground poise.
And by the way, Jeff also suggested that we might want to consider a 2U or something. I'm not sure if that fits what we want to do,
Well,
but absolutely.
they might take you more seriously. Most of the one and dones, the people who do one and it fails and they don't do it anymore, they're one use.
Right.
2U shows a real commitment. And of course, a little more money.
Yes, ma'am.
Have you explored the possibility of using one of these crowdfunding platforms? Since you're doing it for educational purposes, there are a lot of people out there who might love to see a pilot like this go
GoFundMe.
forward. Yeah.
Absolutely. It has come up. We have not established anything yet, but absolutely.
Yeah,
I
please
think that's a
do.
good way to go.
Have you been talking to the Stanford VLF group at all?
No, sir. I'd like to.
I recall that they developed a super low power VLF receiver that was space rated. And,
Oh, big money then. That's gonna be big money then. If it's space qualified, then, you know, this is one of the areas.
well, I mean, they may have a couple of these left over from the original project. I don't know.
Yeah.
Well, I think I like everything Jeff said about the Raspberry Pi and the stick and the ferrite core antenna. Yes, ma'am.
So I was just wondering, so you mentioned all these different universities that were partners with your STEMSAT program, and I was just wondering, what are these universities' roles? How do they contribute to the project?
Let me go back and I'll tell you a little bit. And those roles haven't been totally defined yet. The agreement we signed with Vandy pretty much was a technical consulting sort of agreement, that they are going to provide engineering support, analytical support. This is out of their electronics center. They have a huge commitment for electronics in space and all that. A lot of government contracting. So they're planning to do consulting. Florida Tech, Dr. Don Platt is the director of their Space Systems Engineering master's degree program. He has agreed to provide support in the project management and planning area as well as technical. He runs a small aerospace company down in the Cape Canaveral area. Rome State, David Fields is connected with them, and they're basically doing the balloon concept equipment demo with high altitude balloons. University of North Alabama, they're more data collection. They're basically an optical astronomy group over there, but they very desperately want to get involved in radio astronomy. So I think they would take out the garbage if we left them. So, really nice folks. Alabama Academy of Science, we hope to get some small funding from them. And also, there's a wide variety of people in our state of Alabama already working CubeSats. University of South Alabama has a program underway. University of Alabama Tuscaloosa is working on a program.
There's a small place called Auburn that's working too.
Auburn, alma mater. Absolutely. Yes, sir, question? No, you just worry about the deal. And, UAH, they're in Huntsville, I'm sure. You're probably doing some stuff. They're a space grant university, and we haven't worked any with them yet, but, they are sort of all, they're like a black hole. Once you start working with UAH, you just sort of get sucked in.
So I'll give you a little tip about somebody in Huntsville. There's a company called Radiance, and we teamed with them on the Army's return to space. And we built TechSat 1 with Radiance and some other folks for the U.S. Army down in Huntsville. And they are always been interested in CubeSat.
Really?
So you go over there and you say, you got anything laying around? And you want to give us some money?
Okay. Yeah. Did I mention he's my new best friend? AMSAT, Jerry Buxton, VP of Engineering, they're doing the Fox series of satellites. They have moved on pretty much from 1U size satellites now. They're working 2, 3Us, I guess, and
6Us.
Yeah, big stuff. So Jerry said, well, we got a lot of stuff left over here. Maybe you could use some of that hardware. And but they're so busy. And this is the thing with people who are doing CubeSats. It's a lean and mean type of organization wherever you go. They're so overwhelmed with what they're doing that I'm finding out that it's hard to get on their agenda for help. But they've agreed to sign an MOU with us and work with us. And the Spark Academy, this is K through 3 right now. And they're basically mission planning, and they want to have a ground station. They want to set up a ground station. But Jeff just mentioned a cool idea that might even do better, and that is not to need a ground station at all. So I like that. But that's where we are. Basically, I wanted to come and say we're still scrambling around trying to do the CubeSat mission. We haven't given up, but we basically kind of been overwhelmed. But, yes, sir.
I want to re-emphasize the first question you got. The data rate downlink. If you haven't figured that out by now, you better stop and go back to that point. And in particular,
right.
You're not going to put much data down in 2 meters and get an FCC license.
Yes.
Well, that's right. You're restricted by the bandwidth. And also, they've really, we started off doing all amateur-based satellites, 2 meter, and then we went to 432 exclusively, and they're very resistant to that. It's very difficult to get the ARRL and the FCC behind it for satellites. Now, AMSAT has, of course, a preferred position in this.
Right.
And they're trying to protect their spectrum. They don't like the fact that all these universities or populating the LEO orbits with all these handband thingies.
Amen.
And so that's pretty tough. That's why I mentioned that global star system, and you know, it's relatively cheap. And it puts the data straight out to the internet, so any of your STEM schools can go right in and log in and see the data, and now you have global coverage. So
Anybody
wherever
knows
satellite-
CPR, I think I might swoon up here any minute listening to Jeff.
You get the global coverage aspect, and you get the 24/7 coverage with the downlink, and you don't have to maintain any operators at a ground station or deal with wind blowing your antenna over or anything like that.
Yeah, what we're trying to do is 5 or 10-year-old technology. I mean, we're trying to get into something new with old stuff, so I'm liking what Jeff is proposing. A lot.
You know, we would be willing, Morehead State would be willing to sign a technical agreement with you to offer some support if you're having trouble, because we've got our lawyers in check.
Hey, I just might want to come and see that, you know, from a distance.
There's a standing invitation, anybody in the room who wants to come to Morehead State and see our Space Science Center and our Star Theater and our 21-meter dish antenna system and all, they're welcome to come.
We're coming. We'll just work out the schedule. Any other questions? Oh, yeah.
Well, I still didn't understand the scientific aspect of this project. What do you envision the satellite will do? Because as someone said, once you're in orbit 300-400 kilometers up, you are at the mercy of those megawatt transmitters in
Some of which do leak through.
Not necessarily, because now you're above the ionosphere. Where he wants to do his work, the ionosphere is relatively opaque.
Yeah.
And the sources are going to be much stronger out there. Probably consider your 1 over r squared.
Yeah.
When you're up at 400 clicks, that 1 over r squared starts to come into play.
I was thinking of what his upper frequency limit is. And the fact that.
Well, you know, once you get above the ionospheric window, I mean, then other people are doing it better from the ground, because they have more resources. So what you
That
try
might
to
be an
do is,
interesting research topic.
what you're trying to do is you're trying to look at VLF and HF emanations that are below the MUF. And so that's perfect for that. Grote Reaver would have loved to have had a 2.5 megahertz receiver in orbit, because that's where he was looking at his electron density stuff up there.
Yeah, and you know, that's part of the process where we are right now. Exactly what is the science mission? How do we define that? What data are we going to collect and send down? At what rate? In what form? You know.
One of your best approaches might be to talk about space weather, and not so much the radio astronomy aspect, which may be a spin-off or a small portion of what you're able to do, but actually observing the sun. Because they've had many satellites in orbit that did VLF observations of the sun, and NASA has stopped funding the observation of those. So many people at universities have picked a few of those up, but there really is a hole there now for these types of observations. Of course, some of them were out at L1 point, or, you know, out of the ground points, but you know, you could still do useful work there and maybe pave some way.
Yeah, let's talk about that. Yes, sir.
Is there a CubeSat section on the website, SARA website?
Not yet.
That might be a good place to.
Absolutely, absolutely. Now,
Solicit ideas.
the paper that Amelia is going to give tomorrow afternoon kind of approaches that a little bit, because what we're talking about there is trying to correlate, supersede, inspire Earth-based VLF observations with what we might get from a CubeSat. Do those two relate at all? What are we seeing? Common events, that kind of thing. So absolutely. So maybe we need a small mini conference or something at Morehouse.
Did you
Morehead.
cover CubeSats last year in your paper?
Pardon
Do
me?
you recall? Did you cover the CubeSats pretty well last year in your paper?
I thought I did, yes, sir.
Last year's proceedings.
Yeah, oh yeah. And like I said, the full paper is in this year, pretty much, but just kind of wanted to give you an update, let you know that we're still moving, still a pulse there, we're working the problem, and one way or the other, we are going to submit a proposal in November. So Any other questions? Thank you for your interest, by the way. Yes,
Just a question about, do you have a breadboard prototype of any kind now that you sort of can test or?
yes, Dr. Fields, and I don't know if Bogon knows what he's been doing either, but Dr. Fields has been working that issue now for like a year and a half. He wasn't able to come today or this conference, but yes, he's already been doing antenna experimentation, receiver, data rate, all that kind of stuff. But I don't have a good report from him on that to give you. But yes, we are, but nothing's cast in concrete yet. We're still trying to figure out really how we should do it, what makes sense. And I think Jeff has brought up some good ideas today that might be more doable and a little ahead of the curve.
The most expensive part is going to be your solar cell.
And Jerry has some, or at least he had some that he thought we might could use. So that was for a one use, so I don't know.
Well, you might consider deployable panels on your one use to try to get the power up, because you're not going to have enough power. You can generate and sustain about a 1.6 watt load for the passes where you're down there. If you go to the global star thing, you won't encounter that. It's a smaller power transmitter. So there's, the first thing you talk about is your data rate coming down. The next thing you talk about is your power budget, and then you suffer with the size. So those are the kind of the order of the three things you got to worry about. You're only going to have about a half to a third of a U to put your payload in.
Right.
Because you have your EPC, your electronic power converter, you have your CDH control and data handling board, and then you have your transceiver system.
Right.
And that'll take up about 2/3 of a U right there. And then you have to have all the safety stuff in there too.
Yes.
And so so then you don't end up with much space, which is why I said 2U gives you enough room to breathe. You can actually do something cooler.
Well, we're very open-minded at this point, no doubt. So good deal. All right. Any other questions? Well, thank you so much. If you're interested, there are a few hard copies out there you can pick up. But we would very much welcome any additional input from anyone. And if you want to volunteer to help, we're certainly available to accept that. Thank you very much.